From Earth Science with Vernier, we're going to do experiment number 21, which is comparing sunscreens. In this activity, we take different sunscreens and see how much UV light each of them blocks. The way to test that is to set up a 4x6 card with some nice evenly cut holes, and then on the back of the card we tape down a piece of plastic wrap, and then we label each of the holes for which sunscreen is going to be in each of them. And we keep one as the control so that we have a nice controlled experiment. For each of the holes, what we do is take a little bit of the sunscreen, and unlike skin, the plastic is not going to absorb any of the UV. So you just need a very little bit, rub it evenly over the hole, and then you'll want to wipe your hands between each application of the sunscreen because you don't want to pollute your samples. When taking the data, it's important to not get any of the sunscreen on the sensor. So when we take the UVB sensor, what we're going to do is have the sensor facing the side with no sunscreen on it. And when we first put it into the ring stand, we're going to clamp it down to hold it even, and that'll make it easy to keep the same distance between the card and the sensor in each of our samples. Next, we connect the UV sensor into any of the 4 channels on the top of the Labquest. It will automatically be identified and will be ready to collect data. We could also do this activity with the same sensor and a GoLink or a LabPro interface connected to a laptop, but because the Labquest is so portable, it makes a really nice way to do this activity outside. The first thing we need to do is position the sensor so that it's pointed directly into the sun and make sure that we get good even lighting through the entire activity. The angle on the clamp lets us point it straight at the sun, and the way to sight it is to use the shadow until it goes to the smallest possible dot. That way we know we're pointed straight at the sun. We place a thumb over the sensor to zero it before we begin the run. So we just choose 0 in the software, and that defines that reading as 0. Now we get our card ready with all the different UV values, and we need to make sure that we keep the sunscreen on the side away from the sensor so that we don't get any of the oils on the tip of the sensor. We hit collect, and then we're going to collect data from each of the different samples for several seconds, starting with the control and then moving up in the UV protection factor of the different sunscreens. In the actual lab, we go for 20 seconds on each sample, but here we go for more like 15 seconds. Okay, so looking across our data here, we can see a few interesting things. So in the first part of the data, we see that we have a pretty high reading of over 600 milliwatts per square centimeter, and that's where we had our control group and absolutely no UV protection. When we go down to the first sunscreen, which was a UV4, it drops by quite a bit. When we went into the 8, it drops by quite a bit more. And then for all of the subsequent runs, it drops, but not nearly as dramatically as it did during that first one. You should note that the application of the sunscreen can greatly affect the shapes of the graphs. If you put on a lot more of a low UV factor sunscreen, you can actually get quite a bit more protection than with just a little bit of a high UV protection sunscreen. This is a great way to compare different sunscreens. The same apparatus can also be used to test how much UV is blocked by different cloth, or even to compare cheap sunglasses to expensive sunglasses. For another variation on the same type of earth and environmental science activities, we also make a UVA sensor which measures the intensity of a different set of wavelengths.